Chapter 6, Trigonometry. Looking at exercise 601, trigonometric ratios. Now, remember, a trig ratio, you need to have a marked angle, theta or whatever else. I'm remembering with right angle triangle, if this is theta, this is the adjacent side, this is the side opposite theta, and this is the hypotenuse. We all know our basic three ratios from SOHCAHTOA. Okay, so we know those. SOHCAHTOA represent sine theta is opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. So apart from these three ratios, there are also three inverse, or we can call them reciprocal ratios. Now, reciprocal is 1 over, or in the case of a fraction, the flipped version of the fraction. So, you know how sine theta is opposite over hypotenuse? There is a ratio for hypotenuse over opposite. So we can do hypotenuse over opposite. That ratio is called cosec theta. So, as you've learned, sine theta is opposite over hypotenuse. Cosec theta is hypotenuse. It's the reciprocal ratio, or the inverse ratio. The flip is hypotenuse over opposite. Another one is sec theta. It's the reciprocal of the cos ratio. So sec theta is hypotenuse over adjacent. So sec theta is hypotenuse over adjacent, not adjacent over hypotenuse. And the last reciprocal ratio is cot theta, which is the reciprocal ratio of tan, which is adjacent over opposite. So to remember these three ratios, look at the third letter of the inverse or reciprocal ratios. You don't look at the third letter of the original ones. You look at the third letter of the reciprocal ratios. So the third letter of cosec is what? S. So it's the reciprocal of the sine ratio. So cosec theta, third letter is S. So cosec theta is the reciprocal, or is the reciprocal or the flip of sine theta. Does that make sense? If we look at sec theta, so sec theta is the reciprocal of cos theta, because let's look at the third letter of sec. It's C, so the third letter is a C, so it's the reciprocal of the normal ratio that starts with C, which is cos theta, and cot theta is the reciprocal of tan theta, because the third letter of cot theta, third letter is T. So please don't look at the original ratios, because you know what the original ratios are. It's the new ratios that you don't really know what they are. So you look at the third letter of those, and so it's the reciprocal or the flipped version of those other ratios. So we just looked at the inverse or reciprocal ratio definitions. We're now going to look at complementary ratios. In Year 10, we did look at one of these. All right. So I'm just going to draw another right angle triangle. Now, if this is theta and this is a right angle triangle, then isn't this size of this angle up here what? 90 minus theta. Okay. So in relation to, sorry, I'm going to do this twice. So if this is theta, this is 90 minus theta. So in this first triangle, I'm just going to do the ratios from theta. And then in this second triangle, I'm going to do the ratios from 90 minus theta. So in this triangle, if this is my theta here, then this is adjacent. This is opposite, because I'm in red, right? And this is hypotenuse, right? And if 90 minus theta is my reference point in my second triangle, then this is my hypotenuse, this is my opposite, and this is my adjacent. It depends what is your reference angle. First triangle with reference, well, I'm referencing angle theta, but you'll see that anyway. So with reference to theta, what's sine theta equal to? What's sine theta, isn't it? Opposite over hypotenuse. Okay. How about I go angle A, angle B, angle C, again angle A, angle B, angle C. The triangles are identical, right? So I'm going to call my hypotenuse small c. What should I call my adjacent, little a or little b? Little b, because it's opposite angle B. I'm going to call my opposite side little a, but I've got the same triangle here exactly the same way. Hypotenuse is little c. Adjacent this time is, well, little a is opposite capital A and little b is opposite capital B. Okay, so looking at the first triangle with reference to theta, sine theta is opposite over hypotenuse, which is A over C. All right, cos of theta is what? Adjacent over hypotenuse, which is B over C. Tan theta is opposite over adjacent, which is, all good, A over B. Now, probably should have, I've got to do the 6 ratios. Let's just do sine, cos, and let's just do sine of, now this time we're going from the other angle, sine of 90 minus theta this time. Not sine of theta, sine of 90 minus theta is what? Sine is always opposite over hypotenuse, but this time it's B over C. Now, I'll keep going. Cos of 90 minus theta. So I'm doing cos, but from this angle here. Cos is always adjacent over hypotenuse, which is A over C. And tan of 90 minus theta. Tan is always opposite over adjacent. So opposite over adjacent, it's B over A. Now, we can already see some that are the same. So what I'm going to do, I still need to do the other ratios, but so I might just do them first actually. I need to keep going. I need to do cosec. So we need to do cosec, sec, and I'm going to do cot. Okay, so cosec. Here we go. Cosec theta. Now cosec's third letter is C. S, sorry. So it's the reciprocal of the sine ratio. We know it's hypotenuse over opposite, which is C over A. Are we okay with that? Sec's third letter is C. So it's the reciprocal of the cos ratio. So it's hypotenuse over adjacent. And hypotenuse over adjacent is C over B. And the last one, cot. Cot's third letter is T, so it's the reciprocal of the tan. So instead of opposite over adjacent, it's adjacent over opposite, and adjacent over opposite is B over A. So we're going to do the same thing now with the reciprocal ratios for the 90 minus thetas as well. So these ratios here are with reference to the angle 90 minus theta. So we've got cosec of 90 minus theta. So cosec's third letter is S, so it's the reciprocal of the sine ratio, so it will be hypotenuse over opposite, which is C over B. Sec's third letter is C. It's the reciprocal of cos, which is hypotenuse over adjacent, which is C over A, and cot of 90 minus theta. In other words, we're taking the cot of this angle. It's the reciprocal of tan, because the third letter is T, so it is adjacent over opposite for this triangle, which is A over B. Now, notice that we've got 6 combinations. We can see in green, for example, that first outlined one, that sine of theta equals cos of 90 minus theta. Now let's just work with the sine cos thing again. We can also see that the cos of theta, so I'm just going to keep that in green as well, equals sine of 90 minus theta. So we've got the sine of theta equals the cos of 90 minus theta, but we've also got that the cos of theta equals the sine of 90 minus theta. Sine cos seem to be a pair, okay? For example, if theta was 30, sine of 30 equals cos of 90 minus 30, 60. Sine of 30 equals cos 60. Or if theta was 30 here, cos of 30 equals sine of 90 minus 30, which is sine of 60. They're called complementary ratios because complementary angles add up to 90. So if, for example, if theta here is 10, sine of 10 equals cos of 90 minus 10 equals cos 80. So 10 and 80 make 90. So that's why they're called complementary ratios. But there is also a giveaway in the name, which I will explain. So when you look at sine theta, it really means, you know how I'm saying not sin? It actually is sine theta. That's what it means. And when I write cos theta, cos is actually short for cosine. Cosine theta. Now, if you look at the words sine and cosine, what's the difference between them? Co. Co for complementary. Okay? Now, that's our first rule. It's sine and cos, therefore sine and cos are complementary ratios. Okay? So I can say sine and cos are complementary. How do you know that? How do you remember it? Sine means sine, cos means cosine. It's in the words, all right? Sine and cosine are complementary ratios. Okay, but it's from the name of it. Now let's look at, let's do, we can do tan if you want next, it doesn't matter. So tan in blue. So tan A over B equals cot. And cot theta B over A equals tan 90 minus theta, which is B on A. Okay? So we've got these that match and these that match. In the others, we had sine theta is cos 90 minus and cos theta is sine 90 minus. So these are a match too, and it's also in the wording as well. So we have that tan theta is A on B. That equals cot of 90 minus theta. But we also know that cot of theta, sorry, I'm off screen, cot of theta equals tan of 90 minus theta. In other words, tan and cot are complementary ratios. So therefore, tan and cot. So tan and cot are complementary ratios, but it is in the names of these as well. Tan, do you know what tan means? It's got to do with gradients. It's tangent. Tan theta really means the tangent ratio of theta, and cot theta, cot actually stands for cotangent. That's what it means. It's just cot is simple for cotangent, like an abbreviation. So therefore, what is the difference in those two words? Co. So we've got tan theta, tan means tangent, cot means cotangent. The difference between them is co. They are complementary ratios as well. And our last set is cosec and sec, and you can see it already. Sec, cosec. But sec means secant, and cosec means cosecant. So our last one is cosec of theta is C on A, so is sec theta. It's also C on A. And sec theta is C on B, and cosec 90 minus theta is C on B. So these two are matches. Now you might want to highlight them in colors, whatever. So I've got that cosec theta, so I'm going to move up now. Cosec theta equals sec of 90 minus theta, and, so that's an and, sec theta equals the cosec of 90 minus theta. So really, sec, I mean, I don't have to write out the full word for sec, but it does mean secant. Sec theta, cosec theta, you can see that one already. The difference between them is co, so they're complementary, sec and cosec. Sine and cos, you learnt in year 10, I think. So the last one's a cot and tan, all right? But please don't get them mixed up with inverse or reciprocal ratios, because the same ones don't go together. See, because cosec's reciprocal is sine. Cot's reciprocal is tan, that one works, but sec's reciprocal is cos. It's not cosec. All right, so reciprocal is different to complementary. So that means that sec theta and, and cot, not cot, and cosec, sec and cosec are complementary ratios. Now we're going to put all this into practice. The ratios, if we want, we can write them all out. So question 7, if sine theta, just some examples, equals 1/6, find the exact values for the following. So sine theta always means, with reference to theta, it is opposite over hypotenuse. So we know that sine theta is opposite over hypotenuse. So in other words, the opposite side is 1 from the theta and the hypotenuse is 6. And how do you work out the remaining side? I'm going to call it x. Pythagoras' theorem. X squared equals 6 squared minus 1 squared. So x squared is 35. X is the square root of 35. Now I can write out the exact values for the other ratios. So therefore I know that that's square root of 35. So now I can write down what the other ratios are. So therefore, so this is what you don't do. You don't go shift sine of 1/6, get an answer and do cos of that. That will not give you an exact value. All right. So you've got to draw up a right angle triangle. Whenever you're given sine, cos, tan, cosec, sec, cot, that's all right angle trigonometry. So you must draw a right angle triangle, put what you've got in, 3 sides to a triangle. If you're missing a side, you use Pythagoras' theorem to find the remaining side. So cos theta is adjacent over hypotenuse, which is, what is it? Root 35 over 6. Tan theta is opposite over adjacent, which is 1 on root 35. Actually, while we're here, let's do sec theta. Sec is the reciprocal of, so underline the C, it's the reciprocal of cos. So you can write it as 1 over cos theta if you want. And that's the other thing you can write. Sorry, I should have probably done that on the first page. I'm going to go back to that in a minute. Cos theta is, so sec theta is the reciprocal of cos. So instead of writing it as hypotenuse over adjacent, you can write it as 1 over cos as well. Cosec theta is the reciprocal of sine theta. You just write it as cosec theta equals 1 over sine theta. That's the reciprocal. Okay? We've got sec theta is the reciprocal of cos, so it's 1 over cos theta. And cot theta is the reciprocal of tan theta, so it's 1 over tan theta. Now with a fraction, 1 over fraction means the flipped version of the fraction. Okay? So please write those in. That sec is the reciprocal or inverse of the cos ratio, so it's just 6 over root 35. Do we get it? It's just the flip of that. You don't have to write hypotenuse over adjacent if you're writing 1 over cos. Cosec is the reciprocal of sine. So cosec, sine was given in the question. What's the reciprocal of 1/6? So it's 1 over sine theta. So it's 6 over 1, which is 6. And cot theta is the reciprocal of tan theta. So that's how we show that it's the reciprocal of tan theta. So it's root 35 over 1, or just root 35. Okay? So we also did these 3 additional ones. Another question here, if sec theta equals 1.4, find the exact values of cos theta, cot theta, cosec theta. So sec theta is 1.4, that is 1 4/10, or 1 2/5. Now you need to write it as an improper fraction, which is 7 over 5. That means we know that sec theta is the inverse or reciprocal ratio of cos. So the 7 over 5 is not adjacent over hypotenuse, but it's hypotenuse over adjacent. So in this triangle, I draw a right angle triangle. Remember, you always draw right angle triangles for sine, cos, tan, cosec, sec, or cot. So hypotenuse is 7, adjacent is 5. So we can work out the missing side. You can just do it in one step, as x is the square root of 7 squared minus 5 squared. That's quicker. So it's the square root of 49 minus 25, which is that square root of 24? 49 minus 25, yeah. Which is, what's that? 4 times 6, 2 root 6. That's 2 root 6. So this is 2 root 6. Okay? So now I can write the exact values of the other ratios. So therefore I can say that cos theta, cos, is 5/7. That one you actually could have just done straight away. You don't need the other value, because isn't cos, so actually what I'm going to do, I know that's true, but isn't it the reciprocal of sec? You know how I've written that sec theta is 1 over cos theta is 1 over sec. Now we were given sec, which is 7 over 5, so it's 5/7, whether you use the triangle or not. Do you know what I mean? But you could just go to 5/7. Cot theta, that's the reciprocal of tan. So instead of saying opposite over adjacent, it's adjacent over opposite. So that is just from the question. You wouldn't even need the right angle triangle to do that one, because sec and cos are reciprocal ratios. Okay? Cot theta, that's the reciprocal of tan. So instead of opposite over adjacent, it's adjacent over opposite. Adjacent over opposite, it's 5 over 2 root 6. And cosec theta is the reciprocal of sine. Now sine is opposite over hypotenuse, so it's hypotenuse over opposite, which is 7 over 2 root 6. Okay? Of complementary ratios to simplify this. Now we know that cot and tan are complementary ratios. So I can decide to make both the cots a tan if I want. So doesn't the cot of 25 degrees, just a little bit of working out here, equal the tan of, see, you know how cot theta equals tan of 90 minus theta? In other words, the theta and the 90 minus theta add up to 90. I can write it as tan of 90 minus 25, or I can just be quicker and say 25 plus what gives me 90? Isn't it 65? So on your calculators, if actually no, I have to show you how to use the calculator. You haven't learned how to do that for cot yet, so we'll still need to do that next lesson. So cot of 25 equals tan of 90 minus 25. So now instead of writing, so what can I do here? What can I replace the cot 25 with? So it's tan 65 plus tan 65 over tan 65, which is what? 2 lots of tan 65 degrees over tan 65 degrees. You okay with that? Tan 65, they're identical. It's like x plus x is 2x. That plus that. Tan 65 plus tan 65 is 2 lots of tan 65. What cancels? Tan 65s. So the answer is 2. Okay? The next one. We know that the cos of 90 minus theta equals what? What does it equal? Doesn't it equal sine theta? Because cos and sine are complementary. So if I'm simplifying that, I just replace the cos 90 minus theta with what? With sine theta, which is 0. Do you get that? Okay, so if I had a plus here, let's say I had a plus in the middle, I'd get sine theta plus sine theta is 2 sine theta. Okay, the next one, you can change either one here. You can change, I like to keep the tan and change the cot, because, you know, we're all used to working with sine, cos, and tan. So what does cot 40 equal? It equals tan 50. It's the tan of 90 minus 40, but it's just easier to know that 40 and 50 makes 90. So tan of 50 plus cot 40 minus 3 tan 50 is just tan of 50 plus tan of 50 minus 3 times the tan of 50 degrees. So what's that? Yeah, it's 2 tan 50 minus 3 tan 50, which is negative tan 50. Okay? So these are fairly easy examples. We'll do some harder ones next lesson. The next one, oh, I've done cot of 50 and tan of 40. You can change, I don't care which one you change. Let's change the cot 50 into tan of 40. So that's tan of 40 over tan of 40, which is 1. Okay? Because cot of theta equals tan of 90 minus theta. Now the last one. These types, the easiest thing here is to know that the 2t, see how we say here cot of 50 equals tan of 40? It's because 50 plus 40 is 90. I wouldn't be writing equals 90 minus. You're going to get yourself into a big mess. What I would just do is that 2t plus 5 plus what? Isn't it that this plus that equals what? 90. That's the easiest way to do it. Look, some people do that equals 90 minus this one, but I wouldn't do it like that. They're complementary. The two of them add up to 90. So 2t plus 5 plus 3t minus 15 equals 90 degrees. That's the easiest way to do it. So what have I got? 5t minus 10 is 90. So 5t is 100, t is 20. Now, if you want, you can set it out the other way, like this, or if you want to use that cot theta is tan of 90 minus theta, you can do that, but it gets messy. So I can go that the cot of this, which is 2t plus, equals the tan, but if you've got numbers, this is much easier. That this value plus this one equals 90. That's what complementary angles are. You don't want to do it the other way. So let's just do it this way, that this angle plus this one equals 90. So with this example here, find m. 55, so sec and cosec are complementary. So 55 plus 2m minus 15 equals 90. It's a much easier way to do it. So 2m plus 40 is 90. 2m is 50. And therefore m is 25. It's a really easy way to do it. That plus that is 90. All right, so don't do it the way the examples show.